Imagine you're trying to fight a global fire, but every single fire department has a totally different definition of the word flame. That's basically the invisible crisis we've been facing in public health. And it all comes down to one simple but incredibly important question. Can we all agree on what a disease actually is?
Right now, the way we define diseases around the world is, well, it's a mess. It's this patchwork of inconsistencies. And it's like a hidden crack in our global health armor that you don't even see until a crisis hits. And by then, it's often way too late.
I mean, just stop and think about that for a second. If one country's definition of measles is completely different from its neighbors, how on earth could you track an outbreak? How could you compare your data? How could you coordinate a response? It would be chaos. And the thing is, this isn't just a hypothetical question.
Okay, check this out. On one hand, you have the European definition of measles. It's super strict. You need a fever, a rash, and at least one of 3 other very specific symptoms. But then you look at the definition from India, and it's much more flexible. It could just be a fever and a rash, or even just a doctor's suspicion. Now, neither one is wrong, but they're not speaking the same language at all.
And we have all just lived through the consequences of this. During the COVID-19 pandemic, these kinds of different definitions created a total fog of war. It led to cases being underreported, people being misclassified, and it basically poisoned the global data we were all relying on to make life or death decisions.
So here's the real problem at the core of all this. We write these definitions down in paragraphs, in plain English. A human doctor can read it and get the gist. They can read between the lines. But a computer, it can't. And that creates this huge gap. It means our most powerful tools, the AIs that could be helping us fight these pandemics, are basically left guessing. They make errors because they just can't speak our language.
But what if we could bridge that gap? What if we could create a kind of universal translator for public health? Well, that is exactly what a new initiative has done. And honestly, it is a potential game changer.
Let me introduce you to the Open Syndrome Definition, or OSD for short. And this is nothing less than a revolution. It's the first ever standardized format for defining diseases that both humans and, this is the crucial part, machines can understand perfectly.
And this is where it all just clicks. On one side, you have your typical definition for something like the flu. It's a sentence that a computer would just have to guess at. But on the other side, that's the exact same definition, but translated into the OSD format. Look how clean that is. It's structured, logical. For a computer, that's not a vague sentence. It's a precise set of instructions. There is zero ambiguity.
Now, the people who built OSD were really smart about it. It's based on a few key principles. It's built for AI from the ground up, so our best tools can finally go to work. It ensures interoperability. That's just a fancy word for making sure all our different systems can finally talk to each other. It's completely open and accessible to everyone, which is huge. And, maybe most importantly, it's designed to preserve the original clinical meaning, so nothing gets lost in translation.
But look, a new language is totally useless if nobody speaks it, right? That's why the researchers behind OSD didn't just create a new format. Nope, they built an entire ecosystem to bring it to life.
They started by doing something that had, amazingly, never been done before. They created the very first library of these machine-readable definitions, a real-life Rosetta Stone for this new language of health. To get things rolling, they started by translating 40 different case definitions. And this covered a huge range of illnesses, everything from COVID-19 and measles to dengue fever. It was a massive undertaking just to get this global effort off the ground.
And they knew from day one that this had to be a global project. It couldn't just be focused on one region.
So that initial set of data pulled from 35 different countries. And as you can see, they made sure to sample from every single continent. They wanted to make sure they had true geographic diversity and weren't biased towards any one kind of healthcare system.
And to make it easy for anyone to join in, they built a really simple tool. You just start with your normal, plain text definition, you run it through their tool, and poof, out comes a perfectly structured, machine-readable file. It's a bridge that anyone can cross.
And they put it all online at opensyndrome.org. They created this central hub where the global community can all come together, browse the definitions, contribute their own, and help build out this incredible open-source library for the world.
All right, so what does this all mean for the future? What happens when we finally tear down these language barriers that have been holding public health back for decades?
While the impact could be profound, it means we could detect outbreaks so much faster because data from different places would suddenly be comparable. We could send resources exactly where they're needed most,
And it would enable a kind of seamless, real-time global teamwork that we've really only been able to dream about until now.
But maybe the biggest leap forward is what this does for artificial intelligence. With standardized data, we can finally build and validate AI detection models that actually work well. We can even train AI models across different countries without ever sharing sensitive patient data. It's a cool technique called federated learning. It's like we're training a single, global brain for public health.
And the potential goes even further. This same framework could be used to standardize not just the formal definitions, but also the early warning signs that doctors look for. That's a practice called syndromic surveillance. This could align our global efforts to spot new threats before they ever have a chance to explode into a crisis.
Ultimately, it all comes down to a really simple truth. Public health is a team sport. It absolutely relies on collaboration. And a shared language, like the one OSD provides, is the foundational tool we need to make that collaboration actually work, and to protect all of us.
Which leaves us with one final, pretty exciting question. If we can get everyone and every machine speaking the same language about disease, are we on the verge of a brand new era in public health? An era where we don't just react to pandemics anymore, but we can actually predict and maybe even prevent them?